Hello, and welcome to European SharePoint Training Week, a week of live webinars, ebooks and blogs from the top SharePoint experts in the industry. Today, I'm delighted to be joined by Michael Noel, who will be talking to you about infrastructure best practices for SharePoint on-premises. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP, and our hashtag is ESPC14. Michael is one of an impressive list of speakers for the European SharePoint Conference, which will take place in Barcelona, May 5 to 8, 2014. Go to www.sharepointeurope.com for more information on the 100 plus sessions that will take place. All of the speakers from European SharePoint Training Week will be there, along with the likes of Dan Holm, Jeremy Tigg, Christian Buckley and Rafael Lukovicskia. After the webinar we will have questions. Type any questions you have for Michael in the question pane in the control panel. Some questions will be selected and answered at the end of the presentation. This webinar is being recorded and you will be notified by email when it is available. And now I'm going to pass over to our webinar presenter, Michael Noel. Hello, Michael.
Great, thanks for the introduction. Let me just get the slide deck started here. All right, so welcome to this session on infrastructure best practices for SharePoint on-premises. My name is Michael Noel, and I work for a Microsoft partner called Convergent Computing, or CCO. We're a gold partner that's involved in doing a lot of work setting up the infrastructure of different Microsoft products for our clients. We've been in business since 1986, and we have a lot of large Bay Area clients, including clients such as Facebook, Clorox, large firms that are generally based out of the Bay Area. However, we've done some international work as well. So the work that I do there also led me to write several books. The most pertinent to this discussion is actually the SharePoint Unleashed series. That's a book that when it originally was written, myself and a colleague at CCO wrote it back on SharePoint 2001. It actually was the second SharePoint book ever written at the time, and we've updated it ever since then, the latest one coming out roughly 2 or 3 months ago now, so it's been on shelves for a while. So a lot of the best practices we'll be talking about are actually included in that book. So if you need another reference, that's a good guide for that. So what this particular session is going to be about, the first portion of it is I'm going to talk about some of the infrastructure changes that have been made in SharePoint 2013. So that's just maybe the first 15 minutes or so. The remainder of the session is going to deal with best practices that would apply to either SharePoint 2013 or SharePoint 2010 if you still have a 2010 environment or you need to architect around 2010. So again, first 15 minutes specific just to 2013, and then the remainder will be specific to either 2010 or 2013. And of course, we're talking the on-premises version of SharePoint as opposed to Microsoft's SharePoint Online service, which is in Office 365, which of course I should note, the way that Microsoft has a lot of the best practices they put into their cloud environments are being presented in this session as well. So the first thing you'll note in terms of SharePoint 2013 from an infrastructure perspective are some of the higher requirements around memory and processor than previous versions require. For example, back in SharePoint 2010, we used to say that the minimum amount of memory in the SharePoint server was 8 gigs of RAM. Well, now the minimum has really been pushed up for any SharePoint server that's in production up to at least 12 gigs of RAM. So, and keep in mind that's a starting point. That's assuming a very low usage, very small number of users, and that you're not creating a bunch of extra application pools. So most of our clients actually generally have servers that are deployed that are in the 16 or 20 or even 24 or higher in some cases gigs of RAM on an individual SharePoint server. So the requirements have gone up, particularly if you're trying to put anything into, like all of your roles onto the same machine, SQL Server, SharePoint. Those all-in-one servers, as we call them, really start with 24 gigs of RAM at a minimum. So just to deploy SharePoint, it's going to require a lot of extra resources. From an OS perspective, the only two versions of Windows which are supported are Windows Server 2008 R2 SP1 or Windows 2012. Now, we do prefer the use of Windows 2012. However, just there's been a slower adoption of Windows 2012 because of the changes to the UI. Not everybody's comfortable with them yet. So it's gotten to the point where it's maybe 60% of the deployments now that we do are on Windows 2012, whereas 40 are still on Windows Server 2008 R2 SP1. From a SharePoint functionality perspective, you're not going to see much in terms of functionality loss between those two versions. The only big changes are made around things like if you're using Hyper-V, for example, that's where a lot of changes have been made at the Windows OS level, but not so much at the SharePoint level. Now, on the data side, the SQL Server side, you do have two choices, SQL 2008 R2 with SP1 or SQL 2012. Now, we highly recommend SQL 2012 because there are some significant changes that directly affect SharePoint in SQL 2012. So it's to the point that any new deployments that we do, I'd say at least 90% of them now are running SQL 2012, whereas there's 10% or less that are still deploying on 2008 R2. And we'll talk about some of those changes later on. I'll actually demo some of the SQL 2012 failover options that you can use within a SharePoint environment. That's towards the end of this session. Other changes have been made. The service application model is still roughly the same as it was when it was introduced in SharePoint 2010. However, they have deprecated a few of the service applications, and they've added in a few new service applications as well. So Office Web Apps no longer runs as a service application. It runs as a separate product. Web Analytics got pulled, and the functionality within Web Analytics is now built directly into the search tool. And the 4 new service applications that were added include what's called the App Management Service, and that's what manages the SharePoint App Store, so keeps track of licenses, how many licenses are being used, and which servers are running which apps, etc. Then there's also what's called Machine Translation Services, or SharePoint Translation Services, which is a very interesting service that we've deployed that does on-the-fly language translation of your documents from one language to another, and it does that by sending it up to Microsoft's Bing translation services. So if you have your documents in one store all in German, you can have those all translated to Spanish or translated to English or whatever the one of the 30-some odd different languages that Microsoft supports as part of that service. There's also what's called a work management service that synchronizes your tasks across SharePoint, Exchange, and Project Server. So if you mark a task as complete within Outlook, it'll go and sync that setting back to your project site or to your SharePoint site as well. And then they also released a new version of the Access Services service application. So that replaces the 2010 version of Access Services. Microsoft introduced a couple new services. One's called the Distributed Cache Service. This is a new service in 2013. What this does is it basically keeps your caching information in sync across multiple SharePoint web servers. So by doing that, it allows you to, for example, have better page refreshes when you're accessing the SharePoint farm. So you'll see that run as a service, an actual service that's running on the Services tab or on the Services applet within your Windows Server itself, and that's the Distributed Cache Service. Another one that they added, another feature that was added into it, is something called Request Management, or RM. This is an enterprise-level feature that's meant to make SharePoint much more aware and knowledgeable of the type of requests that are coming into it. So, for example, you can use the user agent string to determine all the traffic that's coming from iPad clients and direct those to specific servers, or you can actually move requests around from one machine to the next, depending on how much resources a particular machine has. Now, that's not a replacement for that capacity is not a replacement for load balancing. Load balancing is still required, at least from a high availability perspective, to make sure that your traffic is going to multiple servers. But once it gets to one of the web role servers, you can use RM policies to define that some traffic is shunted over to different servers within that farm. Other changes that have been made. One particularly useful change has been the simplification and multiple options added to user profile sync. So if you've ever had to set up SharePoint in the past, you will probably note that the most challenging service application to configure has always been user profile sync. It's caused the most trouble within not just our clients, but across the industry. So Microsoft in this version, what they did is they gave you a simplified option if you want to take advantage of it that's easier to set up, that just does a one-way sync very similar to the way that it worked in SharePoint 2007. So if you want to deploy it that way, it's easier to set up if you don't need to sync anything back from SharePoint back into Active Directory. If you want to, of course, the traditional options that was available in 2010, which is option 2 there, allows you to do a certain amount of write-backs. You can have people make changes to, for example, the mobile phone number within their SharePoint profile and have that sync back into Active Directory. Now, the third option that they added, which is also a new option, is for the large enterprise clients who have a solution like Forefront Identity Manager, like the full version of the product already in place. It's now supported to be able to use that and to be able to then synchronize directly with SharePoint, using an MA that goes straight to SharePoint itself. So the 3 different options, a lot of clients are going to take advantage of option 1 if you just have the simple need to just pull your one-way pull of your profiles from Active Directory into SharePoint. Another change that was made is it's now the default to use claims-based authentication on a web application. So in SharePoint 2013, if you create it through the GUI, in fact, it's the only option in the GUI is to create that web application using claims-based auth. It is possible, I should point out, to make a classic mode authentication there, but you have to do it via PowerShell. You won't see it within the GUI itself. What this means, though, is that you also effectively, most environments running on SharePoint 2010 need to do a claims migration before they actually migrate their content over to 2013, because the default in 2010 was classic mode authentication, and most people simply just choose the default when they were setting up SharePoint. So you'll need to do a claims migration, ideally before you then do a content migration. Your way around that is to provision the web application using PowerShell, using classic mode authentication. Microsoft's trying to discourage that, and in fact, they've indicated that the next version of SharePoint will no longer support classic mode authentication. So it's better to make the move to claims sooner than later. A big change made at the data tier, which I'm quite fond of and a lot of our clients are really happy about, is something called shredded storage. Now, this is a concept in which you essentially your documents stored within your content databases take up less space. And it does that by storing only the deltas between the versions. Now, to understand what shredded storage is, you have to really first understand the way that Microsoft's storing these documents. And it stores them as what are called binary large objects, or blobs, is what we refer to them as. Prior to SharePoint 2013, every version of every document was stored as a full-size blob. So if you wanted to, if you had a 50 megabyte document and you were storing 10 versions of that document, and even though there's only 1 megabyte of changes between each version would be stored as a 50 megabyte blob. So you'd be taking up roughly 500 megabytes within that database. Well, in 2013, that same scenario, you'd only be taking up roughly 60 megabytes of space within your content database because it's storing just the deltas, those 1 megabyte changes. So shredded storage, it's enabled for all new documents in 2013. Existing documents that get migrated don't get shredded. It's only new documents that are in there in 2013. But it has reduced the growth curve for a lot of organizations to take advantage of 2013. And then another big driver has been the inclusion of fast search capabilities in 2013. In fact, some of our clients just deployed 2013 farms solely as a search farm, and then they'll get around to migrating their content down in 2010. But they deploy a centralized search farm running fast search so they can take advantage of some of those features. Fast was a product that was originally written by a Norwegian company that Microsoft acquired. It then became a separate search tool back in the SharePoint 2010 time space. But now with 2013, Microsoft has embedded it and included it with all licenses of SharePoint Standard and Enterprise Edition. So you get advantage of this highly complex and very useful search engine that gives you document preview capabilities, personalized search results, contextual previews, etc. That's all now built into SharePoint 2013. Okay, so again, those were information that's specific to SharePoint 2013. The remainder of this conversation is going to apply either to a 2010 or a 2013 environment. So the first thing to understand when you're architecting SharePoint on-premises is that SharePoint is fundamentally a three-tiered application. The web tier is what runs Internet Information Services, and that's where the users connect to using HTTP or HTTPS. The data tier is where all the information is stored, and that's stored on Microsoft SQL servers, so it's stored within your SQL databases. And then there's this middle service application tier, and that service application tier is what runs various shared services like search, managed metadata, machine translation services, all of the things that can be used by multiple servers within a farm and even outside of a farm itself. So each one of these different tiers has different architectural requirements. So for example, a web server will use memory and operating system files in very different ways than a database server does. So if you're just architecting with one set of guidelines, you're going to have performance problems on at least two of these tiers. So the important thing is to make sure that you're architecting for each one of those tiers of SharePoint. Now, in terms of farm designs that are out there, different farm architectural models, you'll see there's what we call the all-in-one. I mentioned that earlier. That's basically throwing everything all in one machine. This is definitely a model that we try to avoid at all costs because you get a lot of contention between the SharePoint roles and between the SQL Server database roles as well. So there's a lot of disk thrashing, there's a lot of memory hogging. It's just, they really don't work that well together. At a minimum, we try to design environments similar to the one that's shown on the right, where at least you have your SQL Server separate from your SharePoint roles, and you've isolated them that way. So it keeps the database off of SharePoint. But what that doesn't give you is it doesn't give you any type of high availability. In fact, in a sense, it almost doubles your chances of an outage because if any one of those servers are down, you're effectively out. Your SharePoint environment no longer runs. So many clients start to look at some of the high availability farm options. And the first high availability farm option is shown here. It's essentially one where you have 4 servers. It's the smallest farm that's fully highly available. In other words, I could lose any one of those servers and my environment would still continue to run. So you see we've got 2 servers of the data tier running as a always-on failover cluster instance or always-on availability groups, which I'll talk about in a little bit. And at the SharePoint tier, we've got our search indexes split across different servers, and as well the web roles running on 2 different servers as well to provide high availability at the web tier. Now, of course, at the web tier, that involves the use of network load balancing to be able to distribute the connections out there. So either hardware-based or a software-based network load balancing. I'd highly recommend the hardware-based one, but that's what provides the load balancing and the high availability at that web tier itself. The downside to the 4-server model is that you don't have any type of split between the service application roles and the web server roles. So in a lot of cases, we recommend what we call the best practice 6-server farm. That's 2 servers running at the web tier, 2 servers running at the service application tier, and then 2 servers running at the data tier itself. It keeps you've got availability across each one of those tiers, and it keeps them all in separate hardware, so you can now architect each one of those servers, for itself, around its own requirements. Now, of course, this does require more in terms of actual hardware, but that's actually where server virtualization can come into play, and I'll talk a little bit about that in some upcoming slides here. One alternative to the 6-server farm still uses 6 servers, but it actually is a model in which those 6 servers are split across 2 farms. And the reason for doing this is actually to isolate, from a patch management perspective, the farms from each other. To give you a reason why someone might consider that, I'll give you an example of a client that didn't have this, that had everything all running on a single farm, and had a failure within their user profile sync service. They called up Microsoft, they opened up a case, and they found that it was a known bug that was fixed by one of the cumulative update patches. Well, at the time, though, they had a freeze in place on any changes made to content. So they couldn't make any type of updates or changes to their content, which effectively meant that they couldn't fix user profile sync for the next several months until they had that change freeze that was over. Now, if they had isolated their service applications into their own farm, they could have potentially gotten around that by updating the farm, by patching it in the service application environment without affecting the content. We'll also see models like this where there may be multiple pools of content, like you have one department or one business unit that has their own farm and another one that has another one. Well, they may go ahead and deploy a centralized service application farm to centralize things like search and manage metadata that are then used by multiple farms outside of that existing centralized farm. So it's important to understand this particular model. We're starting to deploy more and more of those. You will note also I've deployed both farm databases on the same set of SQL servers. Now, it's usually on multiple instances, but they could even theoretically be on the same instance. From a SQL perspective, it's not a problem to have multiple farms running on the same set of servers. And then from a scalability perspective, what I want to demonstrate with this slide is the fact that it is very scalable to take SharePoint and scale it both up and out. So you can scale it up by deploying systems that are dedicated to certain tasks, like certain ones that are just query servers or other ones that run a specific service application like Excel services. Or you can scale it out by just simply adding in more servers at a particular tier. So if your web servers are starting to get overwhelmed, you may add in multiple web servers at that particular tier and expand out that tier to add in additional capacity. So SharePoint can start from a very small environment running on a very small number of servers to a very, very large environment that is handling hundreds of thousands of users at the same time. There's a lot of scalability built into it. In fact, some of what we've been doing with some of our clients is actually building environments that auto-scale based on requirements. So we use tools like System Center Orchestrator, which, together with System Center Operations Manager, that is feeding all the performance data from the SharePoint servers. And if it determines that they're being hit too heavily, it'll automatically provision a brand new SharePoint server and add it into an existing tier. So basically auto-scaling those types of environments out. Okay, which leads us to virtualization. I mentioned earlier on that a lot of our clients are using server virtualization. I'd actually say that if I were to put a number to it, that at least 90% of our clients are virtualizing at least some aspect of their SharePoint farm. They may not be virtualizing all the servers, but in a lot of cases they are virtualizing, and they're virtualizing successfully. So I wanted to cover some of the key points of SharePoint virtualization. Actually wrote the original Microsoft white paper on SharePoint virtualization back with SharePoint 2007, and then over the years I've been involved pretty heavily in this area. So these next two slides are kind of give you some examples of virtualized SharePoint environments, starting with the first sample being one in which in the past potentially everybody would have installed all the SQL roles and the SharePoint roles and everything all on a single server that they have. But what we recommend now is that they take that server, deploy it as a virtual host, and then within that virtual host, now they have the flexibility to break off the database role from the SharePoint role, potentially also to deploy multiple farms, so they could have either production or task farms or different types of farms, all within that single virtual host. And sure, there's some performance overhead which could potentially be lost by using virtualization. It's roughly 5% or so overhead just to run virtualization technologies, depending on the virtualization technology you use. But you gain a lot of that back, and in some cases you may even gain more of it back based on some of the testing that we've done, just by isolating, the SQL Server away from the SharePoint roles and keeping them, from using the same set of OS files and the same memory space and the same processor space. So they all have their own space to work within, and you can more architect and at the same time take advantage of a lot of things like snapshots to be able to recover servers to an older level of which they were before you ran patches, etc. So this type of flexibility can be given just by a single server. Now, some organizations, though, want to actually have have multiple servers that are set up for high availability using server virtualization. So this next sample shows an environment that is just using 2 physical hosts. And within those 2 physical hosts, they've broken up a SharePoint environment into that best practices 6-server farm that I talked about earlier. And what they did is then they split those different tiers across the different virtual hosts. So the SQL tier is split. You'll see there's 2 SQL servers there that are split across the 2 hosts, 2 service application servers, and then 2 web servers. This particular environment, actually, this sample that I'm showing, actually doesn't even require the use of any type of shared storage. Each one of those SQL servers has its own copy of databases that are replicated in between them. And again, we'll talk about 2012 AOAGs later, but basically you can see how just any one of those servers could go down and the environment would continue to operate, or at least the production environment there would continue to operate. So even if I lost the entire virtual host, or if I lost any one of those guests, my environment continues to run, and this is, taking advantage of server virtualization, so you can have those 6 server farms without necessarily having to deploy 6 physical servers. The reality is, however, is that most clients of ours actually deploy a mixture of both physical and virtual servers. So, for example, you may see environments in a lot of cases where the SQL servers are kept on physical hardware, whereas the SharePoint roles then are virtualized. And a lot of that is due to the fact that SQL itself is not the best candidate for server virtualization. It can be virtualized, of course, but because it requires a lot of extra memory and processor, you're not getting the consolidation benefits and consolidation ratios that you might otherwise get if you were deploying SharePoint, or if you're deploying other applications other than SharePoint. So this particular model is more common than not. You see the SQL tier outside virtualized, and then most of the SharePoint roles are virtualized. The best SharePoint candidate for virtualization is actually the web role, followed by the service application roles, just particularly some of the query and indexes and search roles within those, and then the database role would be the least candidate. But when it comes down to it, and I should, incidentally, in terms of scalability, I wanted to, on this next slide, point out that there have been some very, very large environments built that were totally virtualized. So we've been involved with some of those. There's some great flexibility. There's some, you can take advantages of different virtualization DR failover options, which wouldn't normally exist if you had things that were running on physical hardware. So it's definitely possible to have a very large environment that's virtualized. However, you have to keep in mind, and you have to watch very closely, some specific areas of performance monitoring, and that's what's listed here in this next slide, is the different, what we call the 4 categories of SharePoint performance: processor, memory, disk, and network. So as long as you have all 4 of those things, processor, memory, disk, and network, properly monitored, and you're making sure that you're not going into the red on any of those, you'll generally be okay virtualizing those servers. So whenever we virtualize servers, we always just pull the perfmon counters around those, and those are the particular perfmon counters that you see there. And we set up different alerts based on those thresholds, so that if the processor utilization starts to go above 90% on a regular basis, we know about it. Or if we see disk queues or disk region writes that are over 25 milliseconds, that's when you want to be notified, and you want to potentially add additional servers into that farm, or re-architect your virtualization tier. These performance counters, by the way, apply to either physical or virtual SharePoint environments, and these come specifically from Microsoft's guidances around the areas in which the percentages of utilization that you should be fitting within for a good functioning SharePoint environment. Okay, I wanted to segue now into data management, starting with to show you kind of a sample design that deals with kind of the information governance and architecture of your content databases. By default, Microsoft makes it too easy to just go in and install SharePoint, and all of a sudden you just have a single content database with a single site collection within that content database. If you don't make changes right there from the beginning, what ends up happening is that you get these massive site collections or these massive content databases that exist in the end. So, we've seen these site collections that are over a terabyte in size, and at that point you can't divide it up into different content databases because a site collection can only exist within one content database at a time. So what we recommend is that you find these logical breaking points within your organizations, and oftentimes they're departments or different business units, and you deploy each one of those departments or business units as its own separate site collection within that hierarchy. So if you see in this particular model here, we have home.companyabc.com, there's a /department managed path, and then each one of the departments like human resources or IT or marketing, they all have their own site collection underneath there. Each one of those site collections exists within its own content database. Therefore, we spread out the database, the databases from the beginning to kind of reduce the overall growth of those different databases. So that's kind of the best practice, is to divide it up. If you don't already have it divided up, if you already have a bunch in a single content database, if it's multiple site collections, you can move them all via full fidelity moves just with PowerShell. That's relatively straightforward. However, if they are all in just one site collection, we generally recommend the use of third-party tools, because the only way to move at that point using the Microsoft tools is doing what we call a partial fidelity move that doesn't move across workflows and misses some other components as well too. There is a technology to reduce the overall size of your content databases. It's a technology called remote blob storage, or RBS. I mentioned earlier that all the documents and their versions are being stored as blobs within the content databases. Well, in general, the reason they're stored as blobs is because SQL Server doesn't really know what to do with them. It can't index them. It's what we call unstructured data. So it just stores it away in this blob, and what ends up happening is you're not really taking advantage of the technologies and the speed built into SQL Server, which handles your structured data much better than it does your unstructured data. So what we found is that a huge chunk of these content databases is actually taken up by blobs, and you can reduce the size of the blobs by deploying a technology like RBS, which takes the blobs outside of the database, puts them in a different storage location, and then refers to them directly when anytime anyone tries to pull the content out. Now, if you are going to use RBS, I generally do recommend you go third party. Microsoft has what's called a file stream provider, but it's essentially a demonstration tool more than anything else, and it doesn't really give you a lot of options in terms of what you can do with it. So we usually do recommend you go third party if you are looking at something like remote blob storage. In terms of database optimization, one of the very simple things that you can do to improve the performance of your databases is actually to break up your databases into multiple files and spread them across different disk volumes. That it's assuming, of course, that those different disk volumes exist on different disk spindles, on separate sets of disk spindles. But I will point out, because that will allow you to get the full aggregate disk I/O across all of those different volumes. But what should be pointed out is that even if they are even within the same volume, simply breaking up a file into multiple pieces actually improves the overall parallelization of the traffic going to those databases. So we oftentimes do recommend you break them up anyway, even if you still are effectively going across the same set of spindles. Now this applies to your content databases. You'll note in the diagram there I have two content databases. One is database A and one is database B. But it also applies to the all critical tempdb file. That tempdb file and performance of that tempdb file is paramount in a SharePoint environment. It's really critical that that you have your tempdb file highly performant. So, by the way, you'll note I've broken it into each one of those databases into 4 pieces, and the exact number you break it into actually really depends on the number of physical processor sockets that you have running on your SQL server. So it's not by the number of core. You may have seen people say break it up by the number of cores. That's not actually true. That's more of a miscommunication of some of the original directives that came out back with SQL 2000. But it's really closer to the number of physical sockets. So in this case, if I have 4, multi-core processors on the SQL server, I've broken it up into 4 pieces. If I had 2, 6-core processors, I'd break it up into 2 pieces generally. There's no exact number here, and we've played around with these in some of the testing, but that more or less aligns with it as the number of physical processor sockets that you have running on those machines. Now, another thing that you can do to break up and to improve performance of your database files is to actually pre-size the content databases and the tempdb file. It's especially important to pre-size tempdb because the default size for the tempdb database is only 8 megabytes, which means that any time that instance is restarted, tempdb goes back to that size, and then it has to auto-grow. So it's constantly auto-growing, and that's putting these small locks in place every time tempdb is growing. So what we recommend is tempdb actually gets pre-sized to something around 20% of the size of your largest content database. I'd say within reason, by the way. You generally don't want a tempdb over around 100 gigs or so. So having an 80 gigabyte tempdb that's split into multiple files is usually, is not a bad thing. That's oftentimes the case with a lot of our clients for performance. Now, for your content databases, pre-sizing can also give you the advantage of having all the data in one contiguous chunk so that there's not a lot of fragmentation. And at the same time, I'd highly recommend you modify your auto-growth settings from a percentage basis to a fixed size. That way, if they do have to grow, they're going to grow in larger chunks, and so it reduces the fragmentation and reduces the amount of time that auto-growth actually has to go into place. So if you look at that diagram at the bottom, or that screenshot at the bottom, it shows a content database which is broken into 2 files, total aggregate size of 50 gigabytes, but there are 25 gig files for each one of those, and then it's got a log that grows by a gig each time you have to add on to those logs. Other best practices around SQL, one is to make sure that you're implementing SQL maintenance plans. There are no maintenance plans put into place natively within a SharePoint environment. SharePoint is doing a certain amount of stuff in the background to keep the databases more or less functional, but it's not doing some critical components. Namely, it's not doing database integrity checks. So make sure you're running a database consistency check or a DBCC on your databases. Reorganize and or rebuild your indexes. Don't do them both at the same time. What we usually do is reorganize the indexes maybe once a week, and then we rebuild them maybe once a month or at most once a quarter. And at the same time, also make sure that you're truncating and shrinking your transaction logs, because if you're not doing that, they're just going to grow. Particularly if you're in full recovery mode, it's just going to grow until you run out of space on that logs volume. So make sure you have a maintenance plan in place to do backups and to truncate out those transaction logs as well. Okay, I wanted to include a table here talking about high availability. We're first going to discuss high availability at the SQL tier here. And this table really illustrates what the comparison of the high availability options which are available, including some of the more traditional ones at the bottom, up to some of these new options. Now, Microsoft has come out in SQL 2012, they came out with a concept called Always On. Always On itself is essentially just a marketing term, but it refers to 2 separate technologies. There's what's called always-on failover cluster instances, or SCIs. That's actually what you'd consider a traditional cluster. So that's a shared storage cluster where you're failing over the disk in between multiple nodes. So always-on FCI is a traditional cluster, but there's this new option called always-on availability groups, or AOAGs. And AOAGs are kind of a marriage of both clustering and mirroring technologies at the same time to provide you for some very aggressive SLAs. So, for example, if you look at your potential data loss or your recovery point objective, your RPO, it's 0 in synchronous mode with AOAG. It's 5 to 7 seconds for failover, your recovery time objective. So there's some really aggressive SLAs that you can get out of an environment running with an AOAG. So just to demonstrate, show you a slide of how far you can take an environment running with always-on availability groups. I've got one that illustrates kind of a standard SharePoint setup for an AOAG. And what it is, if you look at that, there's a primary data center on the left that consists of 2 SQL servers. And those 2 SQL servers are synchronously replicating all of the databases, the content databases and the remainder of the service application databases in between the 2 servers. Now, it's also creating a third synchronous replica onto a highly connected data center. And when I say highly connected, I mean you have to have at least a gigabit of bandwidth and less than 10 milliseconds of latency over to that other replica to be able to do the synchronous database commit. So it's synchronously replicating all of the data there, which means that I have auto failover within the 2 servers of the primary data center. If I lost the primary, it'll automatically fail over to the secondary. And then I have manual failover of the entire farm over to that other highly connected data center with that third synchronous replica. Now, other things I can do, I can actually have an additional 2 copies of databases asynchronously replicated to remote locations. The limitation within SharePoint, however, is that you can only asynchronously replicate content databases. The remainder of the databases can only support synchronous replication. By the way, technically the secure store database can also be asynchronously replicated. But the remainder of every other service application, the config one, the search databases, those require synchronous replication, which means we can't replicate those over to a remote location because there's just, you won't have the bandwidth and you won't have the latency to be able to do that to those remote locations. Now, what you can do is you can get a copy of your content databases over to those remote locations, and that at least is something that you can do to piece together your farms. But you have to have separate farms in those locations because the farm members also can't go across these long WAN links as well. So keep that in mind. It gets a little bit complicated. You also notice I have what I call a warm farm there. There's some options where I can snapshot those content databases and attach myself to the snapshot version and then have a read-only farm in those locations. And if you're curious about that, you can email me or ping me on Twitter or something later, and I'll go into more detail. But this does change a lot of the design options in terms of how you plan for availability, particularly within that data center. So I wanted to actually go in and show you a live demo of how AOAGs work. So I'm going to go into my demo environment that I have running within my home lab here, and I'm going to actually shut off my SQL server to show you what happens when I'm actually failed over into this environment here. So what happens in the event of a failover. So right now within my home lab, I have a domain controller session. Just to give you the lay of land here, I've got 2 SQL Server sessions that are running as an AOAG, and then I've got a SharePoint web role server as well too. And all of those are running together at the same time. Let me show you on my domain controller session here. These are my SharePoint sites that I'm connected up to. And I'll just refresh them here to show that these are live sites. They're refreshed. Let me pop over to the SQL Server just to show you real briefly the always-on availability group and what that looks like. So I have 2 availability groups, SPDB Content and SPDB Server App. That's, again, to give me the flexibility if in the future I want to add remote replicas to the content databases, I can do that. So right now, SQL 02 is the primary server, which means that SQL02 is the one that's running, the activities coming into SQL02. If I take a look, for example, on SQL02 at the activity monitor, the activity monitor on that machine, I'll see connections being made to SQL02 from the SharePoint server. So SharePoint's pointing to this name. It's a name that's shared in between those two servers. The cluster that we're using is what we call a shared nothing cluster, so it's not sharing any disk. You'll see here's the SharePoint connections being made here. But it's not sharing any disk. What it's doing is it's just sharing the name, and the name is this listener name. So SharePoint thinks it's connecting into a SQL server called SPDB Contents, but in reality it's connecting to SQL02 right now. So what I'm going to do is I'm going to shut down SQL02, and we'll see what the failover process looks like. So let me actually now go over to SQL02, and I'm going to right-click on it and do the equivalent of pressing the power button on that machine. So I'll go to Turn Off, and that's going to turn off the server. You sure want to turn it off? Yes. It'll start to turn off the server. Now, if I go back over to the domain controller session that I have, I'm going to refresh the page. Now, I mentioned the failover in production environments can be 5 to 7 seconds. In my home lab, it's closer to, I'd say, 30 seconds just because I don't have the resources of a production environment. While you have a failover taking place, you can sometimes get some strange messages within SharePoint, but eventually the environment should come back up. So we'll sit here and wait. See, this is one of the messages that oftentimes comes up. You get some strange errors. If people aren't in it at the time, though, many times they won't even note that the failover takes place. So what's happening in the background is the SQL server, SQL1, which was getting synchronous copies of all that information from SQL2, suddenly notices that SQL2 goes down, and it talks together with what's called the file share witness, which is another vote, and they determine whether or not SQL01 should come online. And if they determine that it should, if they have 2 out of 3 votes, which they would in that case, they'll turn SQL01 on, and then SQL01 will be available for the connections from SharePoint. So a lot of the time that is really just waiting for the connection. So here we go. It's failed over. You'll see it's failed over my the site, the home.companyabc.com. It's resetting it back up, and let me just refresh this one here. SharePoint Central Admin should come back up as well too. So you'll see the SharePoint sites come back up. There we go. The site has now come back up, and if I go over to my SQL server, I should see the machine, if I connect to SQL01, is now failed over to the first server here. My replicas will show me SQL01 being primary. So everything's failed over to SQL01, and now the connections are being made from the SharePoint server over to SQL01. We should see those connections right now with the SharePoint server directly connected over to SQL01. So failover, pretty simple, pretty straightforward to set up. Doesn't require a lot. The only thing it does require is an Enterprise Edition version of SQL 2012, because unfortunately you can't do AOAGs with the standard edition version of SQL 012 or SQL 2012. It's only on the Enterprise Edition. Okay, a few other things about high availability that I wanted to talk about before we jump into a question and answers session here. One is just around the concept of network load balancing. I mentioned earlier that network load balancing is how you do high availability to the web tier. Well, I also said I recommend hardware. I want to reiterate that. It is highly recommended to use hardware-based load balancers if you're doing load balancing to a SharePoint environment. Those include, things like F5s, Citrix NetScaler, Cisco equipment, Kemp Technologies are another ones we've worked with a lot. The reality is that a lot of these load balancers are much cheaper than they used to be in the past. It used to be much more expensive to go out and purchase a load balancer. Hardware-based load balancers, they're pretty easy to set up and they just work. Software-based load balancing still is supported. However, there's a lot of caveats around that. One is that it's a layer 2 technology, which means you need to carve out a layer 2 VLAN within your layer 3 switch to get it to work properly. Also, you have to keep in mind the difference between unicast and multicast. If you're using unicast, you need 2 NICs on the servers, one for communications between the nodes. If you're using multicast, you need to set up a special router configuration for that. And you also need to ensure that in the SharePoint environment you have your set to single session affinity or what they call sticky sessions. And by the way, that applies to a hardware-based load balancer as well too. That ensures that once the user has made a connection to one web server, they'll continue to use that web server unless it goes down. And that's to avoid interrupting some of the session information in between that takes place between the client and the server itself. Okay, the last thing I wanted to talk on was the security and documentation. The slide shown here lists what I call the 5 layers of SharePoint security. These are the different layers of security which oftentimes don't get addressed in many organizations, but which are critical to properly securing your environment. And that includes things like physically securing your servers, making sure that you have the best practice number of service accounts. There are a lot of security reasons why you need to do that. And by the way, the minimum number of service accounts you need within a SharePoint environment is 5. It's usually closer to 7 or sometimes more, depending on how your environment is set up. Make sure you also are using Kerberos authentication instead of the very insecure NT-Landman authentication. And then other concepts around data security. We have what's called role-based access control, or RBAC. That's the concept of having a user's role define how they gain access to things. So instead of giving the individual user account rights to a document or to a document library, instead you're giving like their role, like a marketing analyst role. That would be a group within AD that the users then would be a member of, and the marketing analyst role is what's given rights to a particular area within SharePoint. Other areas of data security, one includes encryption. SQL Server includes a tool called transparent data encryption that basically you can encrypt the databases without SharePoint even needing to be aware that the encryption is taking place. So that's the SQL Enterprise Edition feature that we've used to have a lot of to give them compliance with encryption standards. And then at the transport layer, you know, if you're not going to deploy any or just one of these things that I list here, at least deploy SSL. And that's, by the way, not just to external internet-facing SharePoint environments. We generally recommend SSL internally as well. A lot of things that would stop people from deploying SSL in the past, it usually was the processor hit that would have on a SharePoint server. Well, today, with modern processors, the amount that you lose to SSL is generally only 1% of that system's performance. So it's really quite small compared to what it used to be, and it gives you that extra layer of encryption so that people can't just grab the packets going between the client and the server. If you want server-to-server, then that becomes IPsec. You can do IPsec in high security scenarios. And then we generally do recommend you secure the edge. So if you've ever connected SharePoint up to the internet, rather than directly connecting it to it, make sure you have some kind of device in place. We used to do a lot within, you know, the Forefront TMG and later on the UAG line, but there's also third-party space for that as well. Companies like, you know, Juniper and Cisco all have modules that allow you to do a form of reverse proxy before you hit the SharePoint server. And the final area of that is rights management. This is a very simple and highly valuable technology which can be built directly into SharePoint, which allows you to use Active Directory rights management services to protect what happens to the content after it's been accessed. So you can limit copy and paste, you can limit the saving or printing of these documents, and you can do that directly from the SharePoint document library itself. So rights management is another great tool which a lot of organizations need to prevent data leakage. And the final piece I wanted to say is make sure you're also documenting your environment, whether that's manually or whether it's with a tool. If you are going to use a tool, I generally recommend a tool called SBDocKit. I've used that for a lot of my deployments out there. If you go to tinyurl.com/SBDocKit, it'll take you up there. It's actually a pretty low-cost tool, and what it does is it looks at your entire farm and kicks out the entire farm config to a Word document. So from a documentation perspective, it's great. It just generates that Word document. You also can do it, use it, run it 1 month and run it the next month to do a comparison between those two different environments. So that's been a highly useful tool just to document any of the changes that you have within your environment. So with that said, we have a few minutes left for questions, and I will transition it over to questions. Please do note my Twitter tag is Michael T. Noel, so I'd Love it if you follow me. That's what I keep around in the SharePoint world. I speak at a lot of events around the world, including, as was mentioned earlier, I'll be speaking in Barcelona next May. Slides for my slide presentations are generally kept on slideshare.net/Michael T. Noel. So take a look there. And if you're interested in contacting our company, you can contact us at cco.com. You can send me an email. I'm just michael@cco.com as well. And the book can be found at tinyurl.com/FP2013 Unleashed. So I'll transition into questions now.
Thank you, Michael, for a great presentation. We've had a lot of questions coming in, so just to start off, can we manage SharePoint permissions with full forefront identity manager groups?
Can they manage the permissions within Forefront Identity Manager was the question?
Yeah.
Yeah, so not directly from the full FIM product itself. Indirectly, you can use FIM to auto add people into different groups that correspond to specific roles. And if you have your RBAC principles in place that I talked about, where those roles are given the right rights in SharePoint, then it can be done. But that's more indirectly. You're not using FIM to enforce any of the security settings within SharePoint.
Okay. Just another question. Is it possible to have a SharePoint standard farm for the service apps and a foundation for a data web? What's the impact on licenses?
So generally speaking, if you're consuming cross-farm, you're going to need a license for any user that's using that service. So you can't just, you can't get away with having all your users within a foundation farm, but then using a service application from a different farm. Once you start using one of those features, generally speaking, you have to, you have to pay for it. But any licensing questions, I also do say, talk to Microsoft, because in certain cases, I know they've set up different types of scenarios. But it's been my experience that you would have to pay for those features.
Okay. Can shredded storage and remote blob storage be used in conjunction, or should they be used independently?
Yes, they can be used in conjunction, and they are. There's in 2013, you get shredded storage no matter if you want it or not, and RBS will just take out the blobs, whether they're shredded or not, and store them in a different location.
Okay, and the last question, Michael. What about SQL database whitespace after a content database detach migration?
So the whitespace within your content databases, honestly, the reality is that there's generally very little whitespace in a content database, because your content databases are oftentimes growing, and so they're expanding and expanding. If you do a lot of mass deletions within that content database, then you may have white space show up within those content databases. So in that cases, in the case of mass deletions or that type of things, you can run within SQL. You can go through and reorganize and kind of clear out the white spaces within those databases. However, in practice, I can tell you most SharePoint environments, we rarely do that kind of thing. It's usually, if we're moving data out of a content database, we usually just get to the point where the data's all gone and we delete the old content database and just remove it, and that gives us a fresh content database somewhere else.
Okay, thank you, Michael. That's all the time we have for questions today. And before I go, I just want to ask one question of you all. Are you coming to Barcelona? For those of you that don't know, the European SharePoint Conference 2014 will take place from the 5th to 8th of May 2014 in beautiful Barcelona. For more information about what you can expect at Europe's largest SharePoint conference, check out our website www.sharepointeurope.com. Currently, we have a range of competitive pricing options with our great early booking offer. Get a 3-day delegate pass from only $9.95. We also have some fantastic group booking offers available. The bigger your group, the bigger the discount. Check out our pricing page for more information. That's all for today's webinar, and hopefully you can join us tomorrow for our last webinar of the week with Simon Garfield, where he will be talking about social. Goodbye and thank you.